Okay guys, Mr. Allen here one more time for our 10-7 video now. We're going to be looking at finding the volume of pyramids and cones, looking at the formulas and then how to apply them. Alright, so the formula for the volume of it, we're going to start with the pyramid here, is 1/3 times B times H. Volume is 1/3 times capital B stands for the area of the base again, right? Area of the base. And H stands for the height of that pyramid, or what is also called the altitude. Okay, so height of the pyramid times the area of its base. Remember, in three-dimensional world, a base is not a singular edge. I don't know how many times I've seen people try to do an example like this, and they say the base is 12. And that is false. The base of this pyramid is the pentagon. The pentagon is the base. The base is a face. And the face that is the base is the pentagon. I love to say that. The base is a face, and the face that is the base is the pentagon. Okay, so the 12 is not the base. It is an edge of the base, right? The base is the pentagon. So, if we're going to apply our formula here, 1/3 times B times H. Now, what's nice is the H there, the height or altitude, that's this guy. This is the H. It's trying to show from the vertex down to the center of the base, that's going to have a height of 15 inches. And so that is our H. So we've got that. It's the B we're going to have to find, right? And so the base is the pentagon. And so we are going to have to go back to chapter 9 when we learned about how to find the area of a pentagon. And so I'm still called capital B here for the area of our base, right up from the formula. And that was 1/2 times the perimeter times the apothem. Remember, little a stood for the apothem. And the P is the perimeter of the shape. Again, we're thinking two-dimensionally here. This is the perimeter of the pentagon. All right, so perimeter of the pentagon. So the perimeter of the pentagon, if I have a little side work here, perimeter of the pentagon, it's got 5 sides. All of them have 12 inches, right? There's 5 sides on a pentagon. All of them are 12 inches. And so that's going to give us a perimeter of 60 inches. Okay, and the apothem is right there, right? That was already kind of given. That was a nice thing. We made you work for the apothem back in chapter 9 when you learned about these, but we're not testing you on that anymore. We want to just see that you can apply certain formulas, and so the apothem is given here. And so the area of the base is going to be the perimeter 60 times the apothem 8.3 divided by 2, which is going to get us 249 square inches. There's the area of the base, and that's what we need into our formula. Again, you always have to remember what are we trying to do here, right? We're trying to do this. Volume is 1/3 B times H. That's what we're trying to do. So we had to find B to do this, and H was again right there, the 15. So we have what we need. 1/3 times 249 times 15. And that's going to get us 1,245 cubic inches. I want to say one thing. This 1/3, well, sorry if you guys were still looking at that, we'll look at it right here. This 1/3, where does that come from? It's kind of this weird thing that just pops in, seems like, out of nowhere for these formulas for pyramids and cones. The cones has a 1/3 also. And actually where it comes from, guys, when we're in class, and it's really unfortunate we're not, because this is one of my favorite kind of days. We get to step outside of our classroom for a minute. What we usually do is actually go out to the track, to the long jump pit, and we play in the sand. And what we do is we have these cylinders and pyramids, or prisms and pyramids, that have the exact same base, exact same height. And so like we might have, to go with this pentagonal pyramid, we might have a pentagonal prism, right? And then, or we have, a cylinder and a cone with the same circular base, same height. Or we had, maybe a rectangular pyramid and a rectangular prism with the same base and height. And what happens is we actually take then, like, again, if there was this pentagonal prism similar to this one with the same base and same height, you would take the pyramid, fill it up with sand, and dump it into the prism. And we would see how many it took to fill up the prism. And it, every time, is 3. 3 of these pyramids fills up one prism with the same base and same height. And so that's why, if you think back to the prism, what we just did in another video, for the volume of a prism, it's just B times H. So now that we're looking at a pyramid, it's the same B and H, now 1/3, because 3 of these would fill in a prism of the same base and height. Anyway, it's this fun little kind of discovery activity. I'm bummed out we can't do it, but that's where the 1/3 is coming from, is that it's just the way that these behave naturally with volume for like bases and heights between prisms and pyramids. Okay, let's get back to it. Here's our last one. Volume of a cone, 1/3 pi r squared h. Again, the pi r squared h, just like the volume of the cylinder, we're looking at 1/3 of it now because this is a cone, and we've cut out some of the volume by making this, curved edge here. And so the h does stand for the height of the cone. The r stands for the radius of the circle, right, in our formula. I like to highlight the formulas here. All right, so if you think about our formula here, we need r and we need h. It looks like h is right here, 21, but the r is right here and we don't know it. Again, guys, think about your tool bag as far as what do I know about right triangles. We know 2 things. There's really 2 tools we have for right triangles. We have trigonometry, which isn't the most helpful right now. You could do it, but the one that's more helpful is Pythagorean theorem. All right, so we have the 2 tools, trig and Pythagorean theorem. This is a perfect Pythagorean theorem problem. If you have 2 sides of a right triangle and you want the third, Pythagorean theorem works every time. Okay, and Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. Right, the legs make the right angle. The hypotenuse is always opposite the right angle. And then we go ahead and square those out and solve for r. So r squared, 21 squared is 441. 29 squared is 841. So when you subtract the 441 from both sides, you get just 400. And then again, we don't want r squared, we want r. So to get rid of the square, you square root. When you square root 400, you get 20. So this cone has a radius of 20. And we're good to go. We can get our volume. Volume is 1/3 pi r squared h. So we got 1/3, third, not half. 1/3 pi, the radius of 20 squared, times the height of 21. And when you do that, it's going to come out to be, it actually does come out to be kind of a nice, even though we divide by 3, it works. We're going to get a 2800 pi cubic feet, or 2800 times pi, 8,796.5 cubic feet, if we actually multiply by the 3.81, right? Again, this is just like before, so many times now. If we leave it in terms of pi versus rounding to the nearest tenth, just follow directions as far as what you're going to do. All right, guys, that wraps it up. Hopefully this goes well for you this week. We're getting close. We're down to it. Only a few weeks to go. Hope you guys are feeling as good as you can. This situation isn't ideal. We're all doing the best we can. I wish I was there with you guys at school. This just doesn't feel right, but we're going to get through it. Everything's good. Hope you guys are rocking it. Talk to you later.